Every single day, there's an invisible guardian standing between you and countless threats online. Today, we're going to pull back the curtain and meet that guardian, the Web Application Firewall, or WAF.
Think about it. When you're shopping or banking or even just scrolling through your social media feed, have you ever stopped to wonder what's actually protecting your information? Who's standing guard at that digital door? Well, the answer is way more interesting than you might think.
So why does this matter so much? The reality is, every single web application we use, from your photo feed to your online bank, is, by its very nature, exposed to the internet. And for an attacker, that exposure makes each one a potential doorway, a way to just waltz right in and get at sensitive data.
To really get why the solution is so important, we have to understand the problem first. So let's start by taking a look at some of the web's unseen dangers, the common tricks that attackers use to break in.
So you've got some heavy hitters here. Things like SQL injection, where an attacker basically tricks a database into spilling its secrets, or cross-site scripting, also known as XSS, where they sneak malicious code into a website, just waiting for the next visitor to trigger it. And these aren't just hypotheticals. These are real-world threats that are happening all the time. All right, so with all these dangers lurking around, how do our favorite apps stay safe? Well, it's time to meet the hero of our story, your digital bodyguard.
So what exactly is a Web Application Firewall, or WAF? Think of it as a highly specialized shield. You see, unlike a traditional network firewall that just looks at addresses, a WAF works at layer 7, the application layer. This means it can actually understand the content of the traffic coming to an app and look for those specific malicious requests we just talked about. So how does it actually do its job? Well, picture it like a dedicated security checkpoint. First, the WAF stands between the internet and the server, so it intercepts all traffic heading to the web app. This setup is called a reverse proxy. Second, it inspects every single one of those requests against a set of security rules. And finally, just like security at an airport, it blocks anything that looks dangerous and lets all the safe traffic pass right on through. Okay, but how does a WAF know what's dangerous and what's clean? How does it make that call? Well, it all comes down to its playbook, the strategies it uses to tell the good guys from the bad guys.
A WAF really uses two main models. The first is a block list. This is like a bouncer at a club who has a list of known troublemakers. It knows what common attacks look like, and it blocks them on site. The second model is the allow list, which is more like a super exclusive party with a strict VIP list. If a request isn't on that list of pre-approved traffic, it is not getting in, period.
Now, as you can probably guess, neither of these models is perfect. A block list might miss a brand new, never-before-seen attack, and a super strict allow list could accidentally block a legitimate user. That's exactly why most modern WAFs use a hybrid model, cleverly combining both approaches to get the best of both worlds.
Did you know, today's WAFs are so much more than simple rule checkers. They come equipped with this really advanced toolkit that makes them way more intelligent, adaptive, and a whole lot more effective.
So let's talk about some of these superpowers. Modern WAFs have these huge, constantly updated databases of known attack signatures. Think of them as the digital fingerprints of threats. They use AI and machine learning to figure out what's normal for an app so they can spot anything unusual. Plus, they have powerful tools for things like bot management and rate limiting to stop those overwhelming floods of requests.
And that AI part, that's a total game changer. By learning an application's normal traffic patterns, what a typical user does, what kind of data they ask for, the WAF can spot anomalies. This helps it catch really sophisticated unknown attacks, and just as important, it cuts down on false positives, where it might accidentally block a real user. This really highlights a critical point. This fight is never over. Attackers are always coming up with new exploits, and that's why WAFs have to rely on those constantly updated signature databases. This steady stream of threat intelligence is what keeps the WAF's bouncers list up to date, protecting us against the very latest threats.
A massive chunk of malicious traffic online isn't even from humans. It's automated bots trying to scrape data, stuff stolen passwords into login pages, or snatch up all the concert tickets in seconds. And this is where a modern WAF just shines, often blocking over 99% of this nasty automated traffic before it can do any damage at all. Okay, so we know what a WAF is and what it does, but let's bring this into the real world. Where does it fit in the bigger picture of cybersecurity? How does it play with other tools, and what are its limitations?
It's really important to understand that a WAF is a specialist.
A traditional firewall is like the main gatekeeper for a whole building. It's just checking network IDs. A WAF, on the other hand, is the personal bodyguard for the VIP, the application itself, inspecting every single conversation. And then you have something like an API gateway, which also works at this layer, but it's more like an air traffic controller, focused on managing traffic, not deep security inspection. They all have their own important job to do.
But, and this is a big but, running a WAF isn't some set-it-and-forget-it solution. It's a constant balancing act. The security policies need to be tweaked all the time to avoid blocking real users by accident. Dealing with encrypted traffic adds another layer of complexity. And all of this has to be done without slowing down the application and ruining the experience for everyone.
So what's the key takeaway here? In today's world, a web application firewall is no longer some optional extra. It's an absolutely critical, intelligent, and essential layer of security. It's the dynamic shield protecting the apps we all rely on every single day from a mind-boggling range of attacks.
From those simple, early rule-based filters to the AI-driven guardians we have today, WAFs are constantly evolving. But so are the threats. Which leaves us with one final thought. As attackers get smarter and their attacks get more complex, are our digital bodyguards evolving fast enough to keep us safe? Thanks for tuning in.